make a difference there. Okay, so Watson, what do we have now? Okay, in the industry, we have working in healthcare, in financials, in public, and we go to many other industry with time. Okay? And we have what we call Watson advisor. That means to help, okay, different user, okay, to improve their decision-making process. And in there we have the advisor in engagement, in discovery, in decision, policy, and partner solution. On the products from Watson, we have two main products, is Analytics and Explorer. Okay? Then we are also using Watson as service. You have, I list here only 8. Okay? And actually we have more, and we invite developers, students, startup companies to develop further application, especially in service. The A service there, here I just listed out so you know what it is, because on the other slide it's too small to put in, the caption to explain what it is about. But, well, this is not important. I just want to mention to you that, okay, Watson can be used as a service. Okay, so that is, we are talking about Watson is a part of cognitive computing. Now we go to cognitive computing. Right? Cognitive computing is not Watson. Watson is only a milestone of a turning point from a programmable computing era to cognitive. In cognitive computing, we have hardware, we have software, we have network deliveries. Okay? And the three main pillars of cognitive computing is machine learning, natural language processing, and hypothesis generation with evidence-based explanation. Well, actually, in Watson, we use 100 of different technologies behind it, but I just want to mention these three pillars that constitute the difference of cognitive computing to the programming computing era. Okay. So that the four main broad capabilities of cognitive computing is discovery, create new insights, and find new value. Like I said, accelerated discovery in research is something which is important. Okay, in a business decision, okay, you can discover a new pattern in marketing and client satisfaction or your client needs. That will make a difference in your business decision. Okay? And that is the decision provide a bias-free advice. Okay, bias-free, you have to take it into consideration as a relative. Okay, because we don't have the absolute amount of data in order to make it completely bias-free. But at least, okay, we use the maximum data available for us. It, of course, is better than just a human-centric hypothesis. We think what it should be, and then we follow up, we chase up on that idea instead of letting the data to help us to guide where we should go, because they are there, and if they are universal, they are complete, and then you mentioned the set of hypotheses you have will be more inclusive than just a judgment from an individual. And then also it can help you to understand and map the immersion patterns and connection. And the last one is assistant, because they can access to volumic information and knowledge, and to help you to assist you on what you are looking for. Okay? So these are the main four main capabilities. But like I said at the beginning, what is really important is big data there, because they help us to solve the problem by penetrating in the complexity of big data. Okay, I'm asked also to cover a little bit about architecture, okay? So I cannot deny it. I mean, this is important as well. The home point in the architecture cognitive system is actually, it is data-centric. Okay? The computing system we have up to now is always processor-centric. That means you have to bring the data to the processor, so it can process it and it give out the output. The problem with that is we are reaching the physical limit, because we have big data, so much data. And it costs so much to bring the data to the processor. And also it reached the limit of heat generated by the transfer of data. And if you read the press report, I think computer consume about 8% of the total energy consumption in any country, virtually. So we reach a limit where we cannot tolerate a further energy consumption and heat generation. And you know that in many cities they even use the heat generated from the computer to heat up the city during the winter. So you know the energy is a very, very critical issue in computing. And then the fixed limit is we cannot we cannot make the component small and small forever unless we jump into quantum computing. And actually that is what we are working as well. But the whole point here is a new idea is what we call data-centric. That means what? That means we bring the processor to the data. It's like you imagine well, not exactly identical, but a simple way of looking at it, like an integrated supply chain. That means you have the resource. You process locally to get some furnished products, and you only bring that furnished product to the end in order to assemble them together. So that is the principle of bringing the processing to the data. So eventually, we integrate the memory, computation, and communication together. And then we have local data movement. That means we don't have transfer of big data from one place to another. And that, and then we have a system highly parallel and highly distributed. So what happens, we want to save for the energy, then we are only what we call event-driven system. That means only the processor works, then it light up, the other will stay off. And then that with the local data movement with event-driven, then we end up with what we call intra-low power consumption. And then it has to be reconfigurable, like I said, like a supply chain. So if some supply you don't need, then it doesn't work. It should stay idle. And then the system has to be compact with, again, any communication, any burst for transfer data is costly in many different ways there. And on the architecture side, there are two current thinkings now, and that is what IBM is doing. We are doing both. One side is we use the current computing system. That is where we use the power architecture. But we don't use, we call it, we make it open. That means we make it available to everybody. Because we need more contribution from everybody to make it, to advance the system much quicker and more substantially. Then we use natural language processing, knowledge representation, knowledge map, We have information retrieval, planning, reasoning, hypothesis testing, and then domain-specific machine learning. That's one side. And what is it about? Actually, if you look in the press about 2 weeks ago, in the US, the Department of Energy, I think the DOE, they gave IBM $340 million, something like that, to build exactly these two data-centric computer for Akron National Lab and Lawrence Station Lab in Berkeley. So the system will have the computing power 10 times more than the top HPC announced just a couple of weeks ago. And that will be a data-centric system. On the other side, IBM also received a funding about $200 million from DARPA. DARPA is a government organization in the US as well, where we try to mimic physically the brain. So we call this a brain-inspired synapse architecture. In that, it will be more on the recognition. That means on the sensing and recognition, because that's why we call it right brain and left brain, although that notion is debatable, but just put it away so we can see the symmetry. One side is very computing oriented, the other side is very on perception, recognition, sensing, etc. Okay, so these are the two main architecture for cognitive computing existing now, and IBM had the honor to be in both. Okay, so the synapse system you see here, okay, where we talk about neuron synapse, axons like processing, memory, and communications. Okay, again, it's data-centric. That means we put the neuron synapse axon all together exactly where like the brain is. On the data-centric system of open power, okay, you can see that, okay, the normal computing system is we have processor, the cache, and the memory or storage, class memory and storage. That is the typical computer architecture we have now. Okay, so in the data-centric, we bring the processor here, we bring processor here and processor here as well. So the processor goes where the data is. Okay? And that is what we call the data-centric computing. So integration of massive data management and computer with complex analytics, optimized workflow, and then move the computation to the data. Okay, so how does this work in the real? Okay, if you see that is what I call the current computing system, right? And that's what we do. And you see, this is a distributed system of the current architecture, and this is what we want to do. And that is, like I said, these are the two computers we will build for Berkeley Lab and for Arco National Lab. Okay. So, what can we, cognitive system does here, okay? It enhances the cognitive process of professional to strengthen decision-making process, okay? It scale up, okay, expertise by elevating the consistency, the objectivity of decision-making across the organization, and of course, accelerate the development of expertise and other capturing the expertise of the top performers, okay? So you see enhance, scale up, and accelerate it in the business process. Okay, so for the conclusion, I invite you, university, faculty members, students, and business community to join in the adventure at the new frontier, where man and machine working side by side, augmenting human intelligence and capability. Currently, we are calling for Watson partner universities. That means IBM helping a number of universities, and they help IBM as well, okay, to teach the students, okay, how to use Watson, okay, especially in creating startups, building applications, and doing research with the capacity we have here. Because the more research, the more information they put in the system, okay, the better it will be. Okay? And currently, you see, in the US, we have Carnegie Mellon, New York University, Northwestern, Ohio, Rensselaer Polytechnic, Stanford, Berkeley, Southampton. In Europe, 3 weeks ago, there's an announcement from Southampton Imperial College and Technical University of Darmstadt They are the partner of IBM in education and research in cognitive system. And more to come. If you look at Technical University of Denmark, Ecole Polytechnique, and Ecole Centrale Super Lake in Paris. Okay, you have HEC, you have Politecnico di Milano, you have University Polytechnique of Madrid, among many other, and actually in the near future also Ecole Polytechnique Federal Zurich also. Okay, so these are the universities joined in hand with IBM in order to advance cognitive system. Okay, so again, as I joining the adventure new frontier, I put in a number of websites here. Okay, that means to build with Watson. What we want is Watson can be only successful to be in the mainstream if we do have application that is pertinent to our daily lives. Okay? And that's why we want to ask you to help the students to build up application, especially if they want to build a startup around Watson or cognitive system. Okay? We do have Watson on the cloud. Okay? That's why I have also the website on building cognitive application in the cloud. And actually it's on Bluemix, and Bluemix is a cloud for development. That is a very, very good system. I would like to invite you to try it, because that is something we can do in an optimum way. And then get started with Watson Developer Cloud. Maybe when you click on this thing, they will end up to the same thing, okay? Because well, a lot of ways to get to Rome. So eventually you can get there, but the home point is I call on you, right, to make cognitive system computing a reality in our daily life. And don't worry that Expo system is going to replace us, because they are there to assist us only. Thank you very much for your attention.
On fait à la fin les questions. Tu préfères? On fait maintenant.
Est-ce que vous avez une ou deux questions qu'on prendrait tout de suite avant de passer au second exposé?
En français aussi. Hein, si
En français aussi.
Oui, il y a des questions. On va faire passer un micro dans la salle. Ceci marche.
Yes, good evening. In English, if it's okay.
Okay.
I have a question about Watson. Does it support other languages?
Okay, that is a very good question. Okay, for now it was built on English, but you know that at University of Trento, they are building. Well, actually, they are one of the active players in the Watson creation, and they are building Watson with non-English languages. And at the Technical University of Darmstadt, okay, they are also doing a system in German and eventually on non-English system as well. And actually, to think about it, at the end, it's not the language, it's a problem. For now, because the Watson is built to play the game in English, so that is for sure in English. But in the future, okay, language is not a problem. The national language is, because like the example I showed the contradictions of some words, the way we use it, so that is the complexity of language. But in the future, okay, I think non-English version you will have it. And actually, I call you on to help in that. Why don't you create a system in German or in French? Because it's up to you. The system is there. It's up to you to put in the data. It's up to you to think of the application to do so.
Merci. Est-ce qu'il y a d'autres questions? Oui, on vous fait passer. Victor, vous fait passer un micro. Je sais pas.
Good evening. Could you elaborate on your experience with the electronic medical record?
Okay. Electronic records. Actually, I can tell you not only electronic but image as well, the radio image. Okay, I did sponsor a big work in Oxford. Okay, on image processing in order to digitalize and harmonize, standardize on the image and make it available to all hospitals and clinics. So a client coming to any clinic, any hospital in the UK, okay, the doctor can have access to everything. Okay? So the processes of digitalization of medical information is a thing everybody do. Okay? And with that kind of digitized information, the access to that person becomes something much easier than you think of the data from image, from iPhone, iPad, and from other things. So if you talk about medical record, that is not a big problem. Because it have in all countries, fortunately, they do have a national interest in harmonizing and standardizing that kind of information.
Thank you. On va peut-être passer à la présentation de Dimitri. On prendra l'ensemble des autres questions. Il y en a, alors, une très courte, il y a un monsieur là en jaune qui veut absolument poser sa question. Et après, on lancera les questions à la fin.
Alors, Watson promises to increase intelligence and capacity of human being. Has it been evidence-based?
Has it been?
Evidence-based. Have you evidence? Because to increase, because you.
What the example I gave is, for example, like in research in pharma company.
Yes, is it a promise or it is already approved?
They are using it. They are using it in clinics, in hospital in US. They're using it in pharma company in Germany, and they're using it in pharma company in the US. But I have to tell you, the information is confidential.
Oh.
Right? The only thing which is not confidential is how to process the administrative paperwork for Social Security in US. That is not confidential, and the efficiency is much higher.
And it will remain always.
Excuse me?
It will remain confidential, or it will be.
They have been using it now. And actually, you go into Google and you do a search on that, and maybe you can see press article on these things.
Merci beaucoup. Je propose qu'on passe à l'exposé de mon collègue Dimitri Constantas, de laisser reposer Diem, et après, on prendra des questions, autant pour l'exposé de Dimitri que pour l'exposé de Diem. Merci de votre compréhension. Donc maintenant, je voudrais vous introduire mon collègue, le professeur Dimitri Constantas, qui est au Centre universitaire d'informatique de l'Université de Genève, qui est un chercheur à la pointe, et dans le domaine de l'informatique, computer science, et il a choisi, depuis qu'il est professeur ici à l'Université de Genève, de s'intéresser beaucoup à l'informatique utile à la société, et notamment de s'orienter sur la technologie des mobiles dont il va vous parler. Je voudrais dire que j'ai eu une chance incroyable de l'avoir comme collègue. Nous avons pu construire un bachelor en sciences de service, ça a été le premier au monde, pour former très jeunes les étudiants, même de management, à comprendre ce qu'on pouvait créer, comment on pouvait innover avec l'informatique. Et ils ont été, la plupart d'entre eux, à ma connaissance, très heureux de avoir ce type de formation. Et on a créé aussi un master dans ce domaine. Et pour moi, je voudrais lui témoigner, quand je l'ai invité, toute la générosité avec laquelle il a mené ces débats pour arriver à faire ce type d'enseignement. Merci Dimitri, je te laisse la parole.
Merci Michel. Je ne serai pas si technique que Diem. Ça sera plutôt d'un niveau plus abstrait, soi-disant. Voyons. Un peu d'histoire. On parle des mobiles. Ce n'est pas quelque chose de nouveau, il était là depuis très longtemps. Peut-être certains d'entre vous vous rappelez encore. Les plus jeunes, ils n'ont jamais vécu. Moi, je voyais tout ça à une époque. Et on arrivait d'avoir quelque chose qui marchait, un téléphone dans la voiture avec un cadran qui tourne. Je ne sais pas si vous l'avez jamais vu. Moi, j'ai déjà vu ça. Et quelque part, aux années 60, on avait des science fiction. Ça vous rappelle quelque chose ce qu'il est dans la main? C'est un téléphone mobile pratiquement. Quelqu'un, quelque part aux années 60, l'a déjà vu. Mais il était dans le cadre de science fiction, un peu trop loin. À l'époque, c'était impensable, c'était trop loin. Et maintenant, on ne sait pas où on s'arrête. On a tout. On a passé des gros appareils dans des appareils qui peuvent mesurer pratiquement tout. Que la puissance dans une petite horloge, c'est plus grand qu'un ordinateur, une mainframe des années 60, 70, 80. La mémoire, ça dépasse largement tout ce qu'on peut imaginer. Je rappelle qu'aux années 80, quand un professeur il a parlé d'avoir une CPU, un processeur avec une mémoire, un cache memory de 1 MB, il était considéré comme un fou. Aujourd'hui, on est bien loin de ça. Demain, on va encore plus loin. Vous avez déjà entendu le Internet of Things? On connecte tout. Quoi qu'il passe, on peut connecter des voitures, on peut connecter des friteuses, on peut connecter des ports, on peut connecter n'importe quoi. On peut connecter des senseurs du corps, on peut connecter les miroirs qui donnent les informations, qui ramassent pour vous. On est pratiquement là. Tout ceci, comme vous voyez, c'est des applications qui existent, sont des appareils disponibles dans le marché, d'un prix ou un autre. Vous pouvez l'acheter si jamais, et vous pouvez l'utiliser. Mais utiliser et aller plus loin. Là, on parle d'après-demain. On commence à parler des mobiles maintenant, carrément sur vous. C'est vous que vous êtes l'appareil qui marche, et l'électronique, il est implanté dans votre corps. Vous avez déjà lu l'implantation de RFID. Certains, ils ont utilisé RFID pour être dans les bars et payer simplement. Le président des banques centrales brésiliennes, il avait implanté un RFID pour ouvrir les coffres. Donc, c'est que lui pouvait l'ouvrir. Mais on va encore plus loin, d'intégrer carrément des implants, celle-ci, dans votre corps. Et effectivement, pas pour des raisons seulement pour jouer, c'est pour des raisons médicales. Déjà, des implants pour les insulines, ils sont déjà là. Et vous rappelez quelque part les maintenant presque défunts Google Glasses qui commencent à disparaître. Maintenant, on passe à quelque chose complètement différent des lentilles de contact qui peut faire des choses. Ou d'avoir des senseurs dans vos dents, à l'intérieur de vos dents. Donc, comme vous voyez, on va loin, très loin. Et qu'est-ce qu'on reçoit de tout ça? Des données. Des données et encore des données dans différents formats, dans différentes formes. Pour faire quoi en réalité? Est-ce que quelqu'un vraiment l'utilise? Est-ce qu'il l'utilise? Est-ce qu'il comprend qu'est-ce que ça veut dire? Est-ce qu'il peut sortir une information utile à part une petite... Toute l'importance, en fait, c'est dans la corrélation des données. On produit des données, on va continuer de produire des données, des masses de données. Les big data, big, c'est petit. Ça, on peut dire géante, des données géantes, encore plus que ça, des teradata. Ce qu'on va produire, ça va dépasser tout ce qu'on peut imaginer jusqu'à aujourd'hui. Mais l'Internet of Things, c'est ça, c'est le cœur qui va récupérer les données, les trouver, les analyser, interagir, et après, on pense qu'il va donner des services à tout le monde, des communautés, business, des personnes, dans la maison, dans le gouvernement. Tout le monde sera capable de les utiliser et de faire quelque chose. Quoi? Ça, c'est une autre histoire. La question à se poser, c'est qui a accès et qu'est-ce qu'il fait avec? Ça, c'est la question qu'on commence à se poser. Effectivement, le Watson peut les analyser, mais Watson, c'est un appareil. En général, comme vous savez, les plus grandes des entreprises, ils ramassent des informations sans savoir qu'est-ce qu'il va servir. On n'a pas encore d'utilisation, mais on ramasse quand même. Comme les souris, parfois. On récupère tout ce qu'il y a dedans pour récupérer. Qu'est-ce qu'on va faire? C'est une autre histoire. Heureusement, aujourd'hui, les plus grandes entreprises, ce qu'ils utilisent les données, c'est pour marketing, de vous vendre des choses. On sait qui vous êtes, par votre téléphone mobile, où vous êtes, dans quel endroit, et on sait de vous proposer les bons produits ou les bons